this demonstration of EPOS-Norway Portal, I would like to explore geohazards in the Arctic. Let's navigate to the portal. First, create a project. So I will call it Svalbard and click Save. And then I can collapse this menu, and I know all my manipulation with data will be saved in this my project. Let's navigate to Search and Find to find my data of interest. So I'm selecting in the bar plot geological data and map layers, and the list of items is reduced, and I know I will be interested in marine geohazard maps. I'm interested in Svalbard slope, angle maps, and then I will deselect the filters, and I want to add seismological data with earthquake list, and I'm interested in these seismic events from Arctic which were compiled within the Interos project. So now I have my datasets of interest. I'm saving it, and now I want to explore the content. So I've switched to display. I have two plot windows here, and I will just modify it because I want to see three different plot views. Now, first I would like to see the events around Svalbard, seismic events in Svalbard. So I will just click the globe to select the map view. If I select the dataset in the workspace, I see the content of the dataset, and I see this latitude and longitude. So let's drag and drop latitude as y-axis and longitude as x-axis. So here we immediately see that the events are located mostly in the Arctic, and now I also want to color code them. So I will use the depth as color code, and I will use magnitude as size attribute. Okay, so this is my map view. I will also adjust the legend, so I will change the depth only down to 50, which means that 50 kilometers deep will be the uppermost color in this scale. And also I want to adjust the size, so I'm clicking the size, and I will artificially increase it to 10, which means that the earthquake number of the size 10 would be this big. Actually, I will try even bigger. Okay, I'm fine with the events. So I'm interested in geohazard around Longyearbyen, which means I'm wondering if there is any risk that a larger earthquake could trigger an avalanche or a landslide around the city. So first I would like to analyze the earthquakes. So I will add also the time plot. So I'm just dragging the time and magnitude into the scatter plot. So I immediately see events here. And also I want to see the table view. So I'm just dragging the seismic events Arctic targeted to this window without pre-selecting the type of plot, and the system recognizes this is a table, so it will render the data into a table view. So I'm having 41,000 earthquakes in this view. Now I want to see only events which are, say, in the larger area around Longyearbyen. Let's see if we have big earthquakes around this place. So I will just make a selection of the map by pressing Alt button and dragging the mouse around. Let's say up to this region. And actually we see there are larger events in the southeast corner of my selection. But still, even those they are bigger, They are still not bigger than, let's say, magnitude 4. But also I would like to see where are these larger events. So I will make another selection by pressing Shift and making another rectangle in the time plot. And now I see also the events are highlighted in the map. So actually I had some bigger events like this one quite close. Let's see the magnitudes. So if I move this rectangle up, actually it's disappeared. So it means these two events here are quite recent. I would say 2005. If I zoom in this way, I'm just pressing the middle button on the mouse and dragging the mouse to the right. I see that happened somewhere in 2005. There are two bigger earthquakes around Eastfjorden. Okay, so this is the first part. Now I would like to see actually how the slopes look like. So I will add a layer to the map. So I will switch now to Svalbard slope angle maps, and from here I will select the first one, Brahet Jutskred Svalbard, and just drag and drop it into the plot view. And now it's rendered also the map. I will just zoom in. Actually now the events are not very much visible. So I will adjust the transparency of the layer. I can zoom in. So actually I see there are quite steep slopes actually around the city, which is more than 45 degrees, I believe. So this is, let's say, my starting point for further investigations. So I will stop this story here, but I will continue to analyze other geohazards around Svalbard. So I will now navigate to the north. But first I will clear all filters and also zoom out. And I want to add another layer, which is from the Marine Geohazard server. So this is connecting to NGU, and I want to see submarine landslides. Just drag and drop them here. And here I see that actually I have landslides just north of Svalbard. Again, I would like to see what events I have in this area. So I will again press the Alt button, make a selection in the map around the landslide body, and also will maximize this plot. So see all events within the window. And also I see that the number of events was reduced in the table to 118. If I am interested in only this few events here, I can zoom in here and I actually see also where they were distributed in time and approximately the magnitude and exact magnitude in the table. Largest event right within the body was 3.8, dated to 2008. If I'm interested in those events, I can click the download button here and will ask me to save the file as comma separated value format. One can also download the waveforms for a specific event. So if I zoom in and make just selection of one event, because the interface is actually suitable for waveform download for one event. In this case, otherwise it would download too large data set. If I click the download waveform, I can choose the date, starting date, and the maximum radius, which is the distance in degrees, which means 1 degree is approximately 111 kilometers. So if I adjust the date to the time of the event, then I can download the waveforms just for that event. So it was 23rd of March. (2008) and starting 18, 28. Let's choose 25, and the end date will be the same, 24th of March 2008. Let's say 18, 35. And here, because we don't have any stations really close by, I would use the degree of 3 and click OK. And here I'm getting the download URL. If I click this button and copy the content, I can switch to another window and paste the URL here and pre-generate the parameters for the query to download the waveform. If I hit enter, it starts processing my request. And here it goes. It's asking me where I want to store my mseed file for that specific event. So in this case, I will just save it here and switch back to EPOS-N Portal. You can also click directly the download button here. Let's zoom out and see if there are any other events or submarine landslides located close to big events. So there are some landslides close to the oceanic ridge right here, and actually some smaller bodies just west of Svalbard. Let's have a look on those. So again, selecting events in the map here, I see there are really low magnitudes up to maybe 2.5. Actually in the table I can see it quite clearly. Yes, 2.5 is the biggest event, and I have 16 events in this area. So again, if I'm interested in investigating further these events, I can just download the dataset by clicking the download button here and saving the files. Another interesting study might be to check whether any earthquakes are actually aligned to known faults. So I've added from the search and find the geological layer, the Svalbard Geology WMS server, my workspace, and now I want to add it to the map. So I just drag and drop the faults and folds into the map. And if I zoom in, I see the faults as black lines in the map. So there are some earthquakes, but I don't see any peculiar alignment clearly aligned with the existing faults in this area. Okay, let's try to check actually what this big cluster looks like. So if we again do in the selection in the map by pressing the Alt button and making a rectangle selection, I'm wondering when this cloud actually started, and in the time plot we see that it started somewhere in let's see, around 2008 with a burst of activity. There was some persistent activity all the time, but it started being more intense in the last, let's say, 12 years. And I'm interested in how it was evolving in time. So I will just make a rectangle also in the time view. So I'm just pressing the shift and making this rectangle in time. I can also make the time window more specific if I click the 3 dots and edit filter. I see that I was just selecting less than 1 year. So I want to actually look at, for example, exactly 1 year. So I can click the date and then choose 5th of June 2007. I will also maximize the magnitude to 8 to be sure that I see all the earthquakes. Also -2 here. So my window is selected. And now if I just drag the window along the time axis, I see also the migration. So it started north, it was migrating southwest, actually southwest, and slightly backwards, and was starting spreading around. Basically persistent activity in the middle. Until now. It was interesting to see that actually the migration started somewhere in the north right now, and then was migrating southwest and then backwards to the center. So it might be another starting point for further investigations.